So, hi everyone. Okay, please. I like to say something. Hi. I'd like to welcome you on the next Cloud Native Prague Meetup. Today there's the theme about the cloud native application architecture. So, can start. We are two of our organizers, me and Pavel. So feel free to ask us about CNCF and also about the Cloud Native Prague if you're interested in more information. So, what is CNCF? I hope that everyone knows the CNCF. It's just a company which helps the open source project to grow. Yeah, find the contributors and also try to help your project to be spread to the world. So maybe you know some most famous project like Kubernetes, Prometheus, and stuff like that. There are more than 100, and I think it's not up to date, but 150 projects. Maybe you know the Selenium and stuff like that. It's also there. So our community, Cloud Native Prague. So we are trying to get the people together which are interested in cloud native technologies. So you can also use our Slack if you wanted to ask us after the meeting, or you can also join with others. If you are interested in the presentation, which are presented on the meetup, so we have slides.cloudnativeprague.cz. It's a link to the GitHub where are these presentations. We also make records of these events. So we have YouTube channel, so records.cloudnativeprague.cz. And also we are looking for sponsors, looking for companies which provides us this venue or any other venue. Or if you wanted to help us with the organizing or speak at these events, so there is the link like involvement.cloudnativeprague.cz. And just a Google form where you can reach us, or you can just write us on Slack, LinkedIn, and stuff like that, of course. So we are not only one community in our region. There are others one like PyCon, GoLang Meetup, Prague DevOps Meetups, and also conferences like the KCD, so Kubernetes Community Days. It will happen this June. So if you are interested in Kubernetes stuff, so you can join there. And also there is DevOps Days Prague event. So first of all, I'd like to thanks CodeNow to provide this amazing space, and also the catering and stuff like that. So please make some applause for them. And they have some black T-shirts with the CodeNow logo. So if you are interested in, so just reach these guys or girls, of course, to get some information. I think that they have speaker, so he will he will say more about the company. So I'd like to also thanks to G2, it's our sponsor. So one more time, please make some applause for them. G2 is the company that can help you with your infrastructure. So if you wanted to take care about the VMware stuff, or you wanted to get some offers about some solutions, so you can ask them. Maybe the guys can raise the hands if you know. So you can ask these guys. They don't have T-shirts, okay. So just remember it, because they can help you with this stuff. As I said, I'm also one of the organizers of the conference, which happens in Prague this year. It will be June 6 and 7. It's KCD Czech and Slovak. So you can use this QR code. It's just a link to the site where you can register it. It's a paid conference, but it's cheap. It's the same as you will just pay the lunch and the food for whole days. So, so today we have two speakers. First is Petr Svoboda, and the second is Václav Brož. So, if you have any questions for the speeches, so we have also Slido, so you can scan the code, or just there is the code which you can write to the Slido. So please make questions there, and then we will answer it. Yep. I will just keep it for quiet. I still see that some guys scan it, so. But you will still see the QR code at the bottom even during the talks, so. But you have the last chance to scan it. I think that you should use it because there can be maybe also some lottery, but I'm not sure if it will be there or not. It's not our job. So that's it from my side, and we can start with the talk. So I'd like to invite the Petr Svoboda, and he can start. So thank you.
Okay. Okay, thank you everyone. I guess it's gonna be in English, right? So, okay. I will quickly talk a little bit about microservices and cloud native. You probably got this, so I will get over. Quickly, who am I? I have started way long. It's like 25 years ago. Basically went to US just after the towers collapsed. The day they have collapsed, I have purchased tickets to US. Startup on some betting failed, whatever, miserable fail, epic fail. Then I came back, another startup, smaller fail. Then another startup that was successful exit, and then I was a bit tired, so I got a job at Monster. I wanted to work for a US company, so that was one of the US companies available here. And later on, I have ended up in IBM. After 6 years with IBM, I was like, I'm too old, so I will try to found one more company, or otherwise I will end up there for life. So I give it a try, and that's when we started Stratox. Noticeable things what we did with Stratox. You have probably heard about Komerční banka, new digital bank. So we did deliver the platform that automates the software delivery over there. The same thing we have done for Partners Bank nowadays, doing for JNT, Raiffeisen. And with CodeNow, we have a couple customers like in the US, Personal AI, Zásilkovna, Paketa, Metrans here. So you have maybe heard some of those. What is CodeNow? Shameless plug, cloud native software delivery platform, simplifying multi-cloud / hybrid cloud software development. And our expertise is going on-prem basically, and working with Kubernetes in on-prem environment. Our focus, because we are all ex-developers from corporate environments, is to, say, well, we want to make life of corporate developers a little bit less miserable. So what I'm gonna talk about, why microservices, what is what, etc. I will just somehow rush through that. Why to do anything at all? Why to do microservices? So this is some, I believe, Microsoft referential architecture for a bank. I would say it's a business view from a consultant's perspective, how complex organization can look like. If you notice something what is very funny, everything is nice and discrete boxes with no overlaps. Everything actually works fine. So cannot read it, but investment banking, business stakeholders, commercial banking, retail banking, etc. Then you have some risk, horizontal, governance, compliance, horizontal, back office, core processing, etc. So everything works great. Then another view is organizational structure, which more or less fits. And again, everything is nice and discreet, So I have a retail banking group over here and taking care of retail customers. But I also have other arms of that company, and they do have different business stakeholders. They have their own budgets and their own priorities, and they hate each other so they don't want to collaborate from principle because they have different set of KPIs and different goals and targets. So that's how it looks like. When you connect these two together, you get this. So essentially, retail banking, that matches this nice vertical, but then you have secured loan origination and you need CRM. Oh, whoa, not so fast. You need that needs CRM, and CRM has history, and everything is at the end connected to each other, compliance and financial modeling and fraud, different business units and everything. So basically, that's how when this gets developed for a certain period of time, you will end up with implementation that looks like this. Basically, it's one big distributed monolith. You can have ESBs in the middle, you can have whatever you want, but essentially everything depends on everything. So it's hard to maintain, and nobody wants to finance it. That's I would say the most common problem that we are seeing is that business stakeholders would like to change something, but they are not willing to finance IT assets of their counterparts. And because their business functionality is hidden across the enterprise, without financing the others, they cannot move forward. Well, and that's a showstopper. So then they discuss and they align and they try to find consensus, and that's difficult and it takes ages. Cloud native, I will skip that probably because you know what it is, but scalable applications, public, private, hybrid cloud. So yeah. What is a bit less understood, I would say, is microservice architecture. So you can speak about domain-driven design, which is a methodology that helps you to define domains that could match, so let's say, business capabilities of that organization. And then within the domains, in the DDD lingo, you have bounded contexts, and they can be implemented as microservices. So there is some connection to that. Nonetheless, it is even originally, this is a Martin Fowler's quote, from 2007 or something like that. Microservice is built around business capabilities. So when we are talking about API of a microservice, it should provide only use case oriented API that takes commands and produces events in general, hence event driven architecture. If you do anything else, sooner or later you will end up in hell because you are exposing internals of the microservice, maybe in a good intention. Nonetheless, it will end up as a distributed monolith sooner or later. So how big is microservice? Famous question. So it should do only one thing, and that thing is given by a business boundary. It should be small enough to fit in your head, there is a term for that, cognitive overload, or cognitive overhead. If you cannot understand by reading, and if you don't know what it does, then it's too complicated, So basically, you cannot, if somebody news come in and you are doing handover of whatever you have been working on to another developer, the handover must not take 2 months, that's just way too big. Small enough that you can throw them away. If you cannot actually throw away the microservice because it's not even with microservices, at certain moment you get to the situation where you say, well, the technical debt accumulated in there is so big, it doesn't make sense to refactor the code anymore. You know, I will keep the API, that's okay, but internally, I will completely rewrite it from scratch. One of the thing is there is no containerless, meaning not a Docker container, but containerless that it does not depend on WebSphere application server or WebLogic or another provider of containers. Basically, it should be self-operatable. So you can embed something into the microservice, but the microservice does not actually have another dependency that has to be separately configured, because if so, and if the microservice itself is not auto-configured, you will end up again in a situation, so how can I configure one application server that is operating 15 microservices and everyone has a different demands? You will end up in hell. So that's that. Therefore, it should be packaged as single executable. Container is fine, you can hide it inside. And generally, you should perceive microservice as you do when you install just another Linux Unix package. Generally, that's how to think about it. Microservices definitely have different VCS or source code, Git roots, Why? You never know who provides it. You have definitely in a bigger organization different role-based access control settings. Somebody is provided by a third-party vendor, something is internal. It definitely is way more complex than in a startup environment where you have single mono repo and everything inside, That works, but if you take a look how big companies are working with monorepo, they have ton of tooling on top of regular Git. So that's why polyrepo is way more common approach, I would say. How do I design microservice? Exactly domain-driven design and Conway's law. For those who don't know Conway's law, I maybe have it. I will explain it later. What is Conway's law? But that's a way how to design the microservice, because you do not have to design everything up front. Refactoring is part of the game. You need to have a tooling, and that's the role of a lot of DevOps automation that enables very cheap and very fast refactoring. But that's how to find out the boundary. You can have common code libraries. In domain-driven design lingo, it's called shared kernel. So I don't know. We were just discussing. So I don't want to install a big fat DMS, because what is DMS? Well, it is just access to metadata about files and documents which are stored in a folder-like structure in some storage. And whether it's file system, S3 or whatever, well, that's probably not that difficult. And all other aspects of DMS like workflows and that's a different domain of problems actually. So you can write a DMS as a library and then share it across microservices, and then you have one microservice that provides that, and other microservices can use the same library to create their own replica of those documents in their own local storage. I will speak about automatic provisioning. I will speak about own your state later. I don't know. Microservice definitely always should own its state. Microservice must not depend on a state which is provided by somebody else. We have a term called microlit. So you have a microservices, business logic, distributed in micro packages, and then you have a monolithic database, which is operated by somebody else, and you have no control over that apart of maybe schema. So that's not a good idea. So microservice should own its state. That's important. It should be provisioned automatically. I should be able to declaratively specify what is the deployment target. GitOps, you probably know that. Microservice should be aware of its status. There is where a lot of misunderstanding between developers and let's say platform providers, DevOps engineers actually comes, that developers, and somebody has to tell them, you need to make the service to be aware of its own state, because the self-healing capabilities cannot be solely provided from the outside. the microservice should be prepared for that. And where to put? Definitely microservices are not for every place in the organization. Yes, I have seen core banking system nowadays in microservices. You can definitely do that. Nonetheless, there is couple characteristics when microservice is viable, feasible, and makes sense. Frequent changes, definitely. And if you think about, okay, this is going to be frequently changed, therefore what it means that the build and deploy pipeline should not be executed in hours. If I'm frequently changing some code and then I'm waiting, 60 minutes for build and deployment, that's not going to make developers happy. It definitely should be independently deployable. Again, something that we are observing quite a lot, that you can deploy this microservice, but there has to be another 15 microservices already running, otherwise it's useless. Thank you. It should be organized around business capabilities. We spoke about that. Isolated and autonomous. This is the thing. The difference between SOA, traditional service-oriented architecture, and microservices is mainly in the thing that in SOA you were providing function on some endpoint, but how that function actually gets delivered, well, nobody knows. Typically, it was just orchestration of another calls. That's welcome ESB. But microservice, on the other hand, should be able to promise that the unit of work will be delivered. Therefore, if I'm saying create customer, the customer will get created. And not that I will get response 500, cannot create customer because the backend system C is currently down. That's not acceptable answer. And this is something that should be solved by software architects and developers and should never be actually compensated later. Own its state, which means, okay, I am creating customer, or I need to actually read some customer data in order to provide some functionality. First name, last name to send notification, very good. Where it leads? Well, it leads to the situation that I need to start consuming events from CRM. From those events, I will replicate this customer ID, first name, last name. That's all the data I need to know as a microservice to be able to promise that I will deliver notification, which actually speaks to the customer with first name, last name. And here comes event-driven architecture. Who will give me the event last name has changed because somebody got married? So I need to know, and it's a different microservice, and I need to have my own replica of the data. Well, that again comes with a price. What if I will lose the replica? And event-driven means eventually consistent. So do all the data between all the data stores needs to be strongly consistent at certain moment? Well, they don't, It's just the fact that somebody has to think about timestamps and provide reliable infrastructure. And suddenly we can speak about guaranteed delivery and how to provide platform that actually guarantees that the event will get delivered. Mobile but addressable, well, where the microservice runs and how do I address it? So again, there were times when I was writing a code that client was actually resolving the URL of a target service which I want to call. Welcome UDDI and all these concepts, super cool. But what if infrastructure change? What if the network topology change? What if somebody says, well, we are moving from on-prem to public cloud, and suddenly everything changes, even the DNS changes. And then what? Then I will be, how the services will continue communicating. You definitely don't want to impact application code just because you are changing network topology. All of that lead to this picture. I like that, if you want to go to the carousel, you have to be at least that big, And this is just the beginning. I will skip these. Of course, everything needs to actually, so quickly. When I want to need new nodes to the, let's say, Kubernetes node pool, it should not take days, it should be quick, I need to monitor everything, and I need to provide the monitoring information, because if I do not, how do poor developers know what the hell is going on, Suddenly they are responsible for 10 different deployment units, and how do they find out that something is wrong, and what is the root cause of that wrong. Application deployment and DevOps culture. DevOps culture means I need the collaboration to happen like that. You know, cannot be that me as a developer, I'm writing a code, I need to deploy it somewhere, and suddenly Argo gives me 500, and I'm lost. And I can start Googling, but I don't have the rights anyway. And somebody tells me, sorry, we have a production incident, you know, tomorrow. So that means I can go home, you know. Designing tips, how to design microservices, divide and conquer, definitely modeling the business capabilities and start from the big, you know, and take a look on the organization from the outside, because the only purpose why the microservices are getting made or being delivered is to fulfill the business capabilities. And the business capabilities are there only for the reason because the organization does business. So first I take a look from outside, what kind of business are we actually doing, for whom? That's the only thing. Talking about microservices, how big is? Well, modular monolith is a very good pattern, and especially for the teams that have no prior experience in integration problems and versioning problems of microservices at scale, start with monolith. You can always make a cut and just make a separate deployment unit from it if you are using interfaces and you are coding against interfaces, not implementations. That refactoring is very cheap. Conway's law, well, why these actually systems, the big systems, fail to support big organizations? Well, it's very simple. Because if you think about it, in past 20 years, it was the thesis was that basically I will buy a BPM software, and the BPM software delivers certain capability, which is modeling processes and executing processes. And then I have a set of people who are experts in how do I actually work with particular BPM product, and I will form a center of expertise around that because those people are productive. And that's how big silos actually gets formed, you know. And then when you need to get something delivered, which is touching business processes, you are ordering a piece of work from the center of excellence. The problem is a wealthier business stakeholder came before you, and then they will tell you, oh, yes, we will do it happily next year. So Conway's law says organizational structure is there. Face the fact, if you're not changing the org chart as part of the digital transformation, you need to cut the business domains into smaller pieces so it better fits the org chart. Because if you will pour enough money for a long time enough, any software architecture or integration architecture will copy the organizational structure. It's inevitable. It always happens. So that's what this clever guy said, well, some time ago. Last responsible moment. Again, when speaking about application developers wants to do something, they typically don't know what they want, you know. Why? Because at the very beginning, when they are thinking, now I would like to do a microservice, they don't know how it will look. Because you don't want to go waterfall. You don't want to spend, you know, half a year thinking about the design. You want to start doing that. I will start, I will code it, I will deploy it. Well, and now I find out it's completely fucked up. So I need to go back, I will refactor, I will make a cut, and I will make 2 of those. And then I will find out, and suddenly the second piece, I should not own it. So Charlie, please take over. And because it's Charlie from different department, I need to put a broker in between us. That's how it actually gets developed in agile fashion. This says, don't try to make complicated design at the very beginning. You will fail anyway. And yeah, this actually comes from domain-driven design. Make implicit explicit. If you think that everybody knows that TNT is an acquired part of our company, and we have acquired it last year. Nowadays, everybody knows. 20 years from now, nobody will remember. How long the code will actually keep running? I don't know. If it is important, make it part of the code. Service choreography over orchestration. Well, from delivery perspective, what it is about, you have 2 types of how to actually make long-running processes happen. Orchestration says there is a central guy which says, you do this, then do that, then do that, then do that. This has a one single nice feature, and that is I can ask about any instance of any long-running business process, single guy, and he will tell me, okay, so onboarding of this customer, that means create a CRM record, generate new documentation, put it to DMS, then open his internet banking, then do this, then do that. Where is instance for this customer? And it is so far. You can ask a single guy. That's orchestration. Single point of querying, very good. Well, single point of failure as well. Each time you change the workflow, you change the orchestrator. Who owns the orchestrator? That's so it comes with a price. Choreography, on the other hand, says, I have done this, here is event what I have done, and I don't care for whom it is important and who wants to do what afterwards. It's very open for extension, very open for change. On the other hand, it's a bit more difficult to ask, okay, so where is the process of the onboarding of this particular customer? Well, that's a tricky question suddenly. Yeah, really. Yeah. Putting it all together, so suddenly why do I do microservices? Well, because I want to actually move the money spending portion under the guy that owns the money, which is a business stakeholder, and therefore create an environment where the money are getting spent and therefore change is getting implemented and therefore time to market could be actually improved. That's why I do it, you know. That's why microservices. But then with each and every microservice I need to talk about that. You know, versioning. How many microservices do I have? How do I roll back to a previous version? How many versions of the given microservices I keep in a container registry forever to last per major builds? I will throw them away. I don't know. Integration again. So a lot of integration schemas, contracts, etc. So it's a lot of topics that on a platform level should be delivered and fully automated. Because if they are not, you will talk to developers a lot. Because each and every developer will be asking questions about that, most likely with each and every microservice. So imagine an organization when you have 50 developers, they all together own 250 microservices. That's a lot of talking. That's a lot of meetings. Some patterns, domain-driven design. Well, yeah. How are we doing with time? I have no clue. 33 minutes. That was fast. So I don't know. I have so many slides. So, but maybe questions. If you want to know anything about whatever, just ask me. I don't know. Is there anyone? There is no one handling the Slido. Yeah. I don't know how to do it. So just ask. Pavle. Okay, I will continue with some more slides. Slido, máme Slido nějaké otázky? Máme.
Chceš otázky teďka?
Jasně, tak já už mluvím půl hodiny, tak bych mohl mluvit ještě hodinu. Jako. However, dependency on some service registry, console, etc. Eureka microservice should somehow get its configuration, join framework ecosystem. Well, yeah, definitely. Service registry, server-side discovery, stay mobile but addressable. We are more in favor of, let's say, Istio service mesh, for example, or something like that. But yeah, why not? Could definitely be. The question is, who is doing the work? You know, from the code of the microservice, I wanna just say I'm calling party service version 1. Where is party service? None of my business. Somebody else, please solve that. And whether somebody, some edge ingress or whatever, will solve it using a query to console, why not? Definitely good thing. It's just that I don't know your password. So.
You shouldn't.
etcd, Eureka, yeah. It's configuration stores for microservices could be definitely used. Yeah, and dependency on some service. Yeah, that's so. I hope I have answered the question. Service registry, good. Yes, definitely needed. Just please don't make client to actually ask the service registry, because then you are putting a business logic specific to particular service registry implementation to the application code. When you will want to throw away console and replace it with something else, you will have to rebuild the whole application portfolio for the whole company, which renders the change literally impossible. So that's why server-side discovery, not client-side discovery. Can the concept of microservices be compared with the structure of dark websites? I don't know, Thor. Sorry, I am dark web newbie. It's about the, distributed computing, definitely. I think I might have something here. Micro frontends, no. I think I had some other presentation. Yeah, this is most of the enterprise business development actually fits this pattern. I'm not saying everything, but enterprise business development is not so complex at the end of the day. You have a storage, stateless, stateful component, stateless component, interacting those two, and then maybe interacting in between each other. But let me. I had something in Ada Kafka. This one. Yeah. Well, from the distributed architecture perspective, what is every microservice architecture is essentially a distributed architecture. And the question is, who will, to the application developers, explain these 8 fallacies? You cannot fully abstract them on a platform level. Sooner or later, they will leak somehow. But as the way how you design the underlying concept of your platform, I can take a look to this picture, for example. So over here, I want to do infrastructure DevOps. I want to automate infrastructure provisioning. And if I will design it in a way that I have 15 completely isolated, separated islands, that are somehow replicated in between each other, I can. But I must not actually expose that complexity to the application developers because their life has to be way easier. They do not understand the infrastructure concepts, they do not speak the infrastructure language, and you will never teach them. And from the business perspective, you don't want Java developer to be 4 hours a day looking into Terraform documentation. That just does not make any sense. So. How to abstract them? Well, basically, again, you need to think about it. So when I was talking about that, when you design a microservice, you think from the business capabilities outside in. So I take a look on what the organization is doing and how it is perceived from the outside. You can do exactly the same when designing a platform. So what are the interaction points towards application developer? They do the software delivery lifecycle. So I can take a look, for example, to this picture. And okay, so in this phase, how does the application developer interacts with me with the fact that I need to provide him all the services and most likely abstract away the complexity To be honest, it's difficult. It's so difficult that's why we are doing CodeNow actually. uh, how to abstract away these complexities exactly, because they will not learn. So you need to provide a nice and shiny coherent API which is use case oriented and create abstraction layer that encapsulates the underlying complexity. The fact that in order for me to version the component, I need to do git tag, I need to actually generate suffix, I have a different pattern when doing monorepo, I have a different pattern than when doing git flow, then I need to actually produce the container and store it to the registry, then set some permissions, so that the fact that I do all of these tasks, that has to be hidden behind a single command. Please version this component now. That's how. And therefore, developers, they will rely on a high-level business-driven API. And from the business perspective, the API does not change. I could give you another parallel maybe. If I will, when designing event-driven architecture, the goal is to talk with business events. Because the business rarely changes. It changes with new feature requests, with new products, but it does not change as often as the underlying technology implementation. So if I do not have I don't know, Nomad service registered event, I can name it like that, but then I will throw away Nomad and I will replace it with something else. So do I actually consume still Nomad service registered event if there is no Nomad anymore? Does not make sense. So I will instead think, okay, it's a service registered event, and the Nomad thing is an attribute of that given event, not in the name, and therefore the event will survive Nomad replacement. And the same way you have to think about how do I provide services to or API to developers. So today is Istio. Tomorrow, Istio will die and will be replaced by some other technology, which will essentially provide the still same service, and that is service mesh. What is service mesh about? Well, I want to have a single, responsible, domain-oriented implementation that takes care of throttling, policing, I don't know, retrying, whatever you name it. If that answers the question. Další otázku máme nějakou ještě? Nemáme otázky? Okay, so 45 minutes. It's just.
We have one more question. So, how to mock service with EDA? What is the minimum domain size and what can be tested together?
Okay. I think I have some there is a hidden thing, you know. What is a domain? That's not so simple answer. It's the architect that says what the domain is. You have multiple layers of architects. You have enterprise architects thinking about the overall organization. Then you have solution architects that do actually think about complex systems that are typically spanning multiple delivery teams or multiple delivery organizations. And then you have application architects. So let's say the solution architect, in coordination with the enterprise architect, they have to make a conclusion what is a domain. Over here, I can make a domain based on shape. So all the circles are single domain. I can make a domain based on color. So I don't know. For example, this example is from BBC. Let me show you over here. So yeah. So BBC has some verticals. What they do, but in every vertical they have a search. And in these two verticals they have articles, and over here are some topics. So should I create a domain of topics, or should I create a domain of children? Okay, and then do I have a value stream which implements the single domain horizontally or vertically? At the end of the day, you will find out in a typically big organization that it will be mixture. You know, the domains can be overlapping. You know, the inner implementations must not be overlapping. So over here, they came up to conclusion, let's create a horizontally oriented domains on the theme. And that domain is owned with a single team, and that team is delivering microservices. So I forgot what was the question.
The question was how to mock services with ADA. What is the minimum domain size? What can be tested together?
So minimum domain size, there is no minimum domain size, I would say. How to mock it? Let me show you another thing over here. So essentially, over here I have some events. That's in check, unfortunately. So every event has a well-defined schema. That schema should be in some registry. So I can have I don't know, API Curio, and I will do a JSON schema or something like that. And therefore I can, number one, and I should do packed tests. So during the CI pipeline execution, I can do basically contract testing. Number one, then I can avoid a lot of mocking, because if the contract test actually is fulfilled, why to mock anything? It's just way more complicated way of validating. But if I need to actually do the end-to-end integration with mocks, I would question the need for that, maybe. Then there is definitely a lot of like producers, or you can write your own mock. So you will say, okay, I need to learn how to actually write to Kafka, you know, this object, you know, serialized using this serializator, and you just create the API, command API which says, kick me in, and I will spit out event, you know, and you need to write external integration test orchestrator then, if that is the thing. So you describe the end-to-end test, and the end-to-end test specification being executed by something exactly knows when to kick to this mock generator, and that mock generator will produce event. But it's just, I would say, try to think about packed testing first, or contract testing. Okay? So 50 minutes gone, 47. Thank you.
So thanks, we will just have a 10 minutes break, and then there will be second speaker, so just take some beer. So, hi. I'd like to welcome the second speaker, Václav Brož from Pump It Up. So please, you take your stage. So.
Green works.
Very nice.
Perfect. Thank you for joining. This talk is going to be about architecture in general, like for cloud native applications. So I must say it's not going to be as rich in content as the previous talk. That was very good, very rich. And I was really impressed about the knowledge. So this is going to be much easier. And I would say I'm even a little bit shy that it's going to be that easy, right? So let's see, who am I? I'm in the IT over 20 years. I started in telecommunications and done application delivery in corporations, also in IBM, also in smaller companies, doing a lot of consultancy. And recently, I have founded Pump It Up, where we do also coding, also cloud applications, and many things around applications in general. Myself, I like anything, any all-round hacking, not only IT, MTB, and father of 3 kids. So just a few words about Pump It Up. So what we do is application delivery transformation. So we usually come to banks and to various corporations, and we try to teach them how to do better application delivery. This goes usually with continuous integration, continuous deployment, test automation, infrastructure automation, and many things around that. We do also test data automation recently. So we have also started to create a cloud-native platform for test data automations, sixpack.dev. And most of the experiences I will talk about is also from that endeavor. Another marketing slide here. If you want to join us next Tuesday, we organize an IT-oriented quiz in Prague. So it's in English. If you have any colleagues and you don't want to go to Čarodějnice, you can join us for an IT quiz, right? It's on meetup.com, it's on LinkedIn. Welcome. And that's it for marketing. So let's go to cloud native application architecture. I was a little bit puzzled when Zdeněk asked me to have a talk about that, because I mean, what is cloud native first? You know, like everybody says cloud native, and I started, you know, Google, ask ChatGPT what it is, and it's not trivial, because some people think it's just Kubernetes, or some people think it's microservices. So what is exactly cloud native? And I tried to do my definition this week, you know, so let's discuss that. So first is that architecture is distributed. Yeah, so this is, it's not only for cloud native, but this is one of the aspects. But the next aspect is the most important. I mean, every layer of the where the applications run can be replaced anytime. This is one of the aspects of cloud native that was not there before. When you had like mainframe or application containers as J2E stuff, etc., you had like kind of a fixed word where you could rely on. With cloud native, you need to be aware that anything can be replaced anytime. Any components needs to be scalable. This is another aspect of cloud native, which is actually one of the biggest advantages, right? So not only the application itself, but also the infrastructure underneath, and any of the combination. And another and also very important aspect, and this is the one that is given usually in some part of the definition, is that every layer or component can be provided as a service. So you can think of, okay, I can provide hardware as a service. This is already kind of cloud native, yeah, because if you can provision hardware on the fly, you can call it cloud. Or you will provision also the VM that runs on the hardware. You will provision the database. This is also cloud native. But maybe you can also go further. You can provision much more. You can provision, why not in serverless environment, you will provision many layers and you will end up by just executing tasks. So this is also cloud native. So if you try to see what is exactly it is, it's any kind of layer and every combination of layer and vertical, which is the kind of business functionality, can be provided as a service. So for instance, if, let's say, we want to provide some notifications to users. So why not to use a service that provides notification to users end to end, because maybe we don't need to develop it. We may use something that is ready, yeah? So, or we will say, okay, we want still our notification templates, so we will not take the whole service, but we will take just the platform that is able to deliver notifications to mobile phones. Or you will say, okay, let's just do also our own notification because we want to have things under control, and we will, let's say, take as a service only the infrastructure that runs this application. So any combination of the layers needs to be thought out as something I can outsource to a service that runs somewhere, and I don't care where, I just pay for it. So this is really new for cloud native, and architects, as I see them in corporations, they are really not ready to take this as a challenge. And usually they end up by replicating the same kind of principles when different principles can be applied now. So besides layers, we also have those microservices. And you will say, okay, we have a distributed monolith, so we don't have microservice, we have services or components. It's actually the same. For each component or each service, you can have also this layer system, and it can be completely different. So you end up with something that grows in complexity. You may have some services that you will put in Azure Cloud, some others that you will put in Lambda function in AWS. You will still have some stuff on-premise where you will have your own hardware, etc. So each service can be provided completely differently, and the complexity just grows. So it's not just about layers, it's also that each service can be built completely differently. Then if you have many services that are built differently, it ends up by managing the communication between those services, which is one of the challenges of the distributed architecture. And it can be very complex. So as this picture was taken from some, I don't know, marketing materials from some service mesh stuff. So, but it's really, you can achieve that already when you develop some startup, let's say some grocery delivery like Rohlik says that or something like that. You can really end up by this kind of distribution with, I don't know, 50 services and the communication between them. So it becomes really messy, and this is also something that I want to talk about. So the challenge of an architect in cloud native is not only how to design the nice architecture with the boxes that don't overlap, as you have heard previously. It's more about how to make it easy to develop, to maintain, and maintaining something like that comes with observability, that developers can really see what happens, and also with how to do increments. If I have something really complex like that, if I want to do a new feature, where do I start? How can I do increments? So also, this is also some aspect that is completely new with cloud native, where you cannot have any more some central enterprise system for enterprise architecture. Okay, there are still organizations saying, okay, we have Archimate, etc. We can put everything in one picture, and we can, have it like printed on a A0 sheet of paper, and we will do some architecture in there. But this is no more a possible approach. Yeah, the decentralization is must-have in this concept. So, as I said, even if you do monolith, if you go to cloud and you don't want to stick with some mainframe or some old-fashioned stuff, you will have the same problems. It's not about the fact that each microservice owns its state, etc. It's about the fact that each service can be designed completely differently, done by a different team, using different programming language, etc. So how to achieve any progress in there? And so here, from now on, I'm going to tell you my opinion on this, and I hope that we will have questions about that. But for me, the architect needs to become a little bit more a developer when designing the architecture, because the observability is something that is key for any cloud-native application. You need to think how developers are going to observe what happens, how they are going to interact with this, even if it's in the cloud or even if it's provided by a platform engineering team, etc. So this is the first concern, how to keep things close to the developers. Because why do we do cloud native? It's for fast development, it's for prototyping, but it's also for scaling. So it's something that needs to stay there. So you can have metrics, you can have logs, traffic, transactions, you can have many aspects of the observability. So typically in old-fashioned ways, like when I started my career in Eurotel, if you wanted to have access to logs in production, and that was the only thing that was there, that logs, you had to ask for a copy of the logs to the operation engineer, and somebody had to validate it, and then you had a copy of the logs shipped as a zip file, and you could browse like what happened in production, yeah, because it was very secure. Today, it's not thinkable that this could be applied. Today, the developer needs direct, even better than logs, yeah. So this is something that architects needs to consider at first, because you have so many possibilities that if you miss that, you just make things worse. The same, errors like notification. Okay, so I'm gonna come back to that later. Second thing that the architects need to consider, and here I agree to a certain degree that it can be done in an agile way, but it makes sense to design the full kind of target state in terms of middleware. So you can have like, let's say, basically 4 types of middleware. Remote procedure call, which can be RESTful APIs, gRPC, and the kind of stuff. You can have object-oriented middleware, which is a little bit old-fashioned, but still applied. Okay, for example, Java RMI, or you can have other concepts like that. Message-oriented middleware. This is something that today everybody trusts as the mantra, like the event-driven architecture is based on message-oriented middleware. So you have queuing, you have message delivery, publish, subscribe, all that stuff. Specific implementations, typically everybody now knows Kafka, right? So this is, or RabbitMQ and that kind of stuff. And then you have transaction-oriented middleware, which is more tricky, and this is more related to this kind of orchestration pattern that I think personally it's still valid, where if you want to understand what is the distributed state of some business asset, like onboarding a customer or something like that, you also need to have a middleware that allows you to handle it easily. Yeah. So in big corporations today, in Czech Republic specifically, many people choose Camunda to be like this kind of transaction-oriented stuff, like to do this orchestration. But you have other options. And this is still something you should consider, because the event-driven architecture has limits. Like when you reach some certain complexity, it's difficult to understand what's the state and to have it also something testable. So then if you have those 2 things defined, like you have let's say the observability and all this kind of feedback loop to the developer, that the developers can easily deploy code to production and also have the feedback loop. Okay, they can observe it, and let's say I like the concept of you build it, you run it, right? Or previously it was called DevOps, but it's basically the same. The developers need to be accountable for production, but also they need to have the means how to understand what happens. Yeah, this is the first thing. So second thing is that the middleware, that is kind of the way to handle communication between all the services components, this is also something that makes sense to define and to have a clear definition what should be there in the organization. And the third is that you can still think of some standard business components or IT components that make sense to standardize and to say we are going to use that stuff. Right? So I will start with the IT. For example, CI/CD. For me, if you design an application, it makes sense to think about CI/CD, where you store your code, how you're gonna do integration tests or unit tests, how you're gonna deploy, to kind of make some standard about that. Because if you start by leaving too much freedom, then it's very difficult to scale the organization, because it's very probable that sometime you will come with some security standards. You will want to have control what packages you use in your code, etc. If you leave too much freedom to the developers, this is going to be difficult to scale. The same is about automated testing. So you may design standards like pack testing or end-to-end testing in ephemeral environments. It doesn't matter, but it makes sense that the architect already, when starting to design the cloud-native application, think about that problem, because if you leave that to the developers, they don't have time to outlook how this is going to work when we will have thousands of customers. So you have all these IT kind of shared components that you can define, but you can have the same stuff at business level. You can say we are going to use like some kind of business interaction service, like I don't know, some forums, online forums to discuss with the customer, or we are going to use a certain UI framework, or some kind of stuff that is already business, Because if you bootstrap, for example, a new application as a startup, you don't want to develop everything yourself. And if you don't define it as an architect, you will very soon end up with too many services that are difficult to integrate. So yeah, you have many kind of aspects of that, and all those aspects you can say, let's just purchase it because we don't have time to develop. So if you're a startup, like we are now kind of 1.5 years doing a startup inside our company, every developer will come with an idea. Yeah, we need some observability, we need some error handling. So let's take Sentry, But then we need some logging. So let's do some other, software for that. And then we need to notify customers about something. So let's take some mass mailing software for that. So everybody has ideas like, yeah, there are many options how to handle things. And this is cloud-native approach. I don't want to develop it. I will purchase it as a service. And as I said, you can do it at various levels. So like infrastructure guys, they will say, let's buy CI/CD, in cloud. That makes sense. Then developers, they will say, okay, yeah, for example, we don't want to operate our Jenkins servers. That doesn't make sense. Let's take GitLab or Azure DevOps or something like that. The same, the marketing guy is going to say, we need Google Analytics. Yeah, it makes sense to have a service. We will not develop this ourselves. And at the end of the day, you will have a lot of services, like you can have like 50, 100 of services like that. It's not a problem of money. It's a problem that once you will want to scale, you will have more developers, you will have more business people. Basically, it's not sustainable. You will want to have some single sign-on, some integration between those services, and it's going to be difficult. So the challenge is to still be cloud native and not to exaggerate it. Yeah. So before, architects were doing like logical architecture, then deployment architecture, then security frameworks, operating model, like sequentially. Like typically, they decided, okay, let's do everything in Java, and then let's purchase some J2E container, and then let's do some component model, etc. So they were doing sequentially, and now with cloud native, they have the freedom to do it by services. They don't need to define everything up front. They can say, okay, the front end, we are going to purchase we are going to do it in Node.js, and we will not have our own infrastructure. We will directly deploy to some Node.js provider. Yeah, so you have many providers like that. And then the backend guys, they say, we need Kubernetes, yeah, because we want to have our own container, so we will have Kubernetes. And then you will have the middleware guys. They will say, I want to have managed Kafka, right? So they will have, they will say, okay, let's have managed Kafka. And they will say, there will be the serverless guys that will say, we don't want anything. We will have Lambda functions or Azure functions or whatever. So architects should kind of allow that to a certain degree. So they should understand that there are those possibilities because it makes sense. It's faster. But if they exaggerate, then it's becoming too difficult to scale. So what is the scaling problem? First is skills, because every developer has an idea how it's easy to integrate Sentry, how it's easy to integrate, I don't know, this tool and that tool, etc. The problem is that when the developer leaves, the other developer that comes after has completely different opinion on that. And also, developers from other teams, they would like to use something different. So it's good as prototype, but it soon becomes a problem. So that's the problem of being too open to cloud native. You need to kind of restrict all the options you have. Second is complexity. As I said, it seems easy because you just put your credit card and you can purchase the service. The problem is that you don't outlook all the problems you will have 1 year later. So the integration between those services might be difficult. So again, the architect is no more here just to define the logical architecture, etc. He needs to consider also the operating model, how things can be maintained over time, etc. So it's a much more difficult position, in fact. And third is cost. So I don't want to go into too much arguing whether serverless is better than having your own infrastructure. But if you see companies, once they reach certain size, there are always guys that kick in and say, I mean, if we do the business case of having our own Kubernetes, it's basically cheaper than serverless. And then if you grow, then you say, basically, if we have enough people to handle our own data center, it's cheaper than purchase Kubernetes clusters as a service. So based on the size of the organization, the outsourcing pattern is completely different. And if you don't think that a little bit upfront and you purchase everything to the top layer, so to, let's say, SaaS or delivering the real value, when you try to scale, you have like hundreds of services. Each of them is roughly a little bit more expensive that you could reach, but you're unable to consolidate them because the complexity is too high and you don't have the skills. So, long story short, even if cloud native is an excellent opportunity to do fast prototyping, to develop things really easily, because you have all these possibilities. You have thousands of services that you can purchase and not develop them. If you don't do the homework of thinking a little bit upfront, you end up with something that is not scalable, and you need to rework it. So typically, until this year, there was a lot of capital. So startups were working like, let's do the prototype, then even before having any customer, let's have some funds. We have A series, B series funding, etc. And every series is just meaning we will rework everything. Yeah, so that's because money was cheap. Today, money is not that cheap anymore. So you need to think a little bit upfront. If you want to scale, we will not have like billions to rework, to refactor everything. So this is like 6 steps that I think everybody should do, like when designing architecture of a cloud native application. So you need to define your language and frameworks. So basically, typically, when you have a CTO, usually the programming language is chosen is the programming language that the CTO knows best. Why not? Why not? This is a good choice, because why not? But it's a choice that needs to be done. It doesn't make sense to have like 10 programming languages in your company. It doesn't make sense. Even if it's possible, it doesn't make sense. Yeah, so you need to define your language frameworks, and typically architects don't do that. Legacy architects, they stick with the boxes, etc., and they don't think about basics like that. Then you need to define your preferred, like the level of outsourcing you want to have in target. So are we going to do with, are we going to have infrastructure as code? Or are we going to purchase all platforms? Or are we going to do serverless? So this is also a choice that you need to do at the beginning. Even if you can do exceptions later, if you don't define that, it's going to be the mess. Third is also very important, and usually architects don't understand it at all. You need to think of your CI/CD and your delivery model, including test automation. And why architects don't do that? Because it's a lot of dirty work. You need to have a lot of scripting experience. You need to know what are the pains that you can have over time. If you don't do that, again, it's feasible. You will have a fast prototype. Once you want to scale and you have 10 developers instead of 2, this is going to break, and you will have consultants coming and fixing it for you for money. So then you need to define security standards. So a typical example is where I will give you my security standard is zero trust, right? But you can have other security standards, like, for example, you can decide we are going to have Kubernetes and everything is going to be namespace closed, no external communication, etc. This is a standard. Or you will say, okay, our standard is that we scan everything with some, scanner of vulnerabilities, etc. But you need to define it upfront, because if you don't, then later it's very difficult to achieve, and when you scale, you need it. So those security standards, they can be very, very easy, very, let's say, lightweight, but you need to think about that. Also, define your target middleware. This is also very important, because typically, I daily work with organizations that have RabbitMQ, then they have Kafka, and then they also have some other GMS. They have some. They have NATs. They have some API gateway. Then they have some service mesh, etc. So they have everything, because it makes sense to have everything. Yeah. So I don't think this is a good way. I think for each use case, or RPC, message queuing, publish, subscribe, and orchestration, you should define just one and say this is going to be our standard. And you can either operate it yourself or outsource it. That's fine, but just have it have a limited number of options here. And then, of course, this target observability standards. So it seems like not architecture, but it's actually one of the most important things of architecture is like to think up from how the developers are going to work with the software during the whole life cycle, not just like how it looks like on my PowerPoint slides. Like how I am going to work with that. If you design the architecture of the building, it's not just about where are the floors, where are the rooms. It's also how people are going through in various situations, like in the morning, in the evening, during the day, when there's fire, etc. So it's the same for the applications. It's no more just a theoretical work that the architects can do with the paper. They need to have some experience. They need to be a little bit developers, I would say. So now, for each of those aspects, I can give you my personal opinion, and why, and explain why. So, for example, CI/CD. I think today, if you start an application, the goal is to have everything as code, like GitOps and stuff like that, and to have full automated testing. So I often say that there's no more testers, there are only developers. And there's no more admins, there are only developers. Because infrastructure is code, testing is code, everything is code. So this is one of the principles that I think it's very, very useful. And in cloud native, it makes sense, because everything is pinnable just by code. So this is the first principle. Developer experience is a priority because everything is code. Second, is the levels of outsourcing. So I have already spoken about it a little bit, but usually you will say, okay, let's go to the public cloud and let's define what services we will adopt, yeah? So we can adopt some serverless environment, we can adopt some databases as a service, we can adopt Kubernetes as a service. So this is typically something that you need to do because it's difficult to change. No, it's not difficult to change. It's difficult to change the skill sets in your company, not from architecture point of view. So yeah, level of outsourcing, and it can be different per domain. It can be, you can still have some variability. So in big organization, what happens is that the top low level layer is typically outsourced to public cloud or to some data center provider. And then you have an engineering team that handles kind of in the middle, provides. So typically in a bank that we were discussing previously, there's a big engineering team delivering the speed platform. So this is it. They deliver things for the developers, and then you have developers and teams in development, and they should be able to handle the rest. You don't want to have too many of those guys that are in the middle. You want typically to have those developers that are able to provision everything underneath automatically. So full CI/CD, I've talked about that. Zero trust. Why zero trust? And this is not easy to convince in big organizations. Zero trust is the concept that the service can be on the internet. If I simplify, you don't trust anything, so all the communication needs to be secured. Any message you receive, you need to be able to verify that it's originating from the right guy, etc. So you don't need that much of security zones and to rely that much on firewalls and things like that. You still need them, and it's a good idea to have everything, like to have also zero trust and also to have firewalls. But in the zero trust, the idea is that you are very free to refactor the level of outsourcing. You can move things from Google Cloud to AWS. If you have zero trust, it's feasible. If you don't have zero trust, that's a pain point because you will need to have some virtual networks that span across the public clouds or even on-premise. With zero trust, I think that's the preferred security standard. And Google have pinned that like for years, I think. So then middleware, so the most modern RPC is like a gRPC, maybe. But I still think REST is better. Why? Because there are so many tools, so many skills in REST that even if I like very modern stuff, I think if you have to decide, REST is still a little bit better than gRPC in that sense. So this is my opinion. Yeah, all those are my opinions. Then for message broker, I recently discovered NATS. So if you remember, we had Apache web servers, yeah? When I started, nothing else existed. It was just Apache. And then Nginx came, and I said, we are going to do it better. And today, everything is Nginx. So the same, I think, is maybe about to happen with Kafka. Everybody has Apache Kafka. But if you look in NATS, NATS is software that does almost the same, but like 10 times lighter and 10 times easier to adopt. So this is a tip for myself. If you have to decide, look at NATS because it's really interesting. It's fully open source, it's lightweight, and it has some features that even Kafka doesn't have. Then I would disagree with the previous talk regarding orchestration. I think orchestration is still required. I mean, event sourcing is very good, but the problem is that you have complex organization and you have a distributed state that nobody knows. It starts to be a problem, especially when you want to test something. If you want to test something in context, let's say a bank, onboarding of a customer, it's a nightmare to test this. And if you think of orchestration for specific cases, this can really help not only the operation, but also testing. So I'm a fan of Temporal for that, because it's everything as code, and it's open source. So have a look at NATS, Temporal. Yeah, those are the two platforms I would really recommend for cloud native stuff where you expect some degree of complexity. Yeah, and for the observability, I have a special trick that developers hate, but I'm a developer, I love it, and I force all of my developers to have that, is that observability is built in the application. It's not an external stuff, you know. It's not that we will implement some tools like that will analyze the log, etc. It should be inside the application. So the application itself should think about being observable. And typically, I like to use it for alarms. So if you have an application and you have just a few developers, you don't want to have, and you want to have them have a good quality of this application. One way to achieve it, that you enforce to have any error from production sent directly to the developer's email or SMS or something. Every error. Of course, you can have some throttling that if there are like 5 errors per second, you will kind of send it only once every minute. But this principle is excellent because you can really achieve like a zero bug concept easily if you do it from the beginning. If you do it after a year, it's unfeasible. But if you start an application in Cloud Native and you implement this principle, basically you have zero bugs after 1 year. And that's excellent because it's scalable. You can have full automation, full test automation because you don't have the bugs. There's no flakiness in the test, etc. So this is a trick to build observability in the applications and not to rely only on external stuff. That's it. As I said, the content is really weak based compared to other talks, and I hope there are some questions so that we can build up contents together.
Sure. There's one question. Two questions on Slido. So, how to architect microservice which is excluding DB transaction in cloud native infrastructure?
Which is excluding DB transactions?
You can read it.
Executing DB transactions in cloud native infrastructure. I'm not sure if I understand correctly, but if I have a DB transaction, either it's handled by the microservice itself, and that's usually microservice should own their own schemas and databases, etc. So then the microservice is fully let's say mandated to do the whole transaction. There shouldn't be any kind of other service doing this transaction. If you have a distributed transaction, we are talking about either event-driven stuff where you need to have some saga pattern with the compensation, or you can do some orchestration where basically you designate a service that's going to coordinate the other services and is able then to do the distributed transaction. But I don't think it's a good idea to have a DB transaction done by different services. Yeah, I would say it's a business transaction done by different services. It's not a DB transaction done by different services. But if the question is from somewhere here, let's, if I'm not correct, if I didn't understand correctly, let's.
Question is really how about ephemeral nature of nodes of I don't know some stuff, and if it's interrupted, it's a business problem. It's I don't know, some order haven't occurred.
Okay. So typically this is handled in two ways. So usually you try to decouple the services with some middleware. So typically you put either a message queuing using some event-driven concept, or you can have this orchestration concept which does similarly, it tries to decouple and to capture the intermediate state that something started but is not finished. Yeah. So in event sourcing, the goal is that unless you process the event, you will not consume it. So then you are able, if your node disappears in the middle, when a next node is going to pick up, is going to reprocess the event. So typically in software like message brokers, message brokers, you have this concept of not consuming a message unless you have fully processed it. So this is one way how to handle that. And in the orchestration, so for example with temporal, there's a built-in feature that does typically that. It retries until you have done your transaction. And then there are the problems you end up with is that if you start the transaction the second time and the first time was not successful, you should be able to cope with that. So it is a word I don't remember, but it's like
idempotency.
Idempotency. So you need to account that everywhere in the code. So the developers need to be aware of that. But that's not the only case when it's a problem. So in cloud native, you can not only have the problem that the node disappears, but you have two nodes, or you have more. It's horizontally scalable. So you also need to account of that when you process transactions, that you will process it only once. And this is typically the biggest problem, because you need to have some system to ensure that. So the most easy way how to do that is to have the database as the single point of truth, and the database will ensure the transaction is done only once. Now, if you want to scale around the globe, like, I don't know, Uber or this kind of enterprises, one database cannot handle that, so you start to have distributed databases where the consistency is eventual consistency. So even there, the database is no more a solution, and you need to account for that. In every single transaction, you need to think of what can happen if I have already done it previously, or what if I have not yet done it at all. So you need to account for that at the code level, at every feature, actually. Otherwise, that's my opinion. Of course, you might have some tools that will try to abstract for that, but my opinion is that at the end of the day, it will not remove the complexity, especially if you scale around the globe, where you have this eventual consistency. You have like hundreds of milliseconds round trip between continents, so you can't do this as previously.
So there's another question. Can you describe some differences between Camunda and temporal?
Yeah, so this is very specific, but it's one of my preferred topics. So one of the key differences is that in temporal, you decentralize the realization of every single task. So from organization point of view, you don't need to have a single team handling, stuff. So you can really decentralize to a higher level than temporal. This is like the main benefit. For example, you can have like various languages. It can reside completely different infrastructure, and also it's very close to developers because everything is as code. So it's just a native code that defines your processes. So that's the main benefit. Like, there's no middle team that's gonna do some design or something. It's just code, and it can be as simple as a few lines of code, or it can be as complex as a full application, and it's still just code. So that's the key kind of benefit of using temporal for this kind of for that.
I haven't heard from you about typical pattern in Kubernetes operator pattern. I didn't hear about typical pattern in Kubernetes from you, operator pattern, and use for distributed communication between services, custom resource definition as interface. So, and you don't need to operator or orchestrator for this temporal Camunda, but every service has their own custom resource definition, and they are communicating between each other through that.
Okay, so when we are talking about Camunda or temporal, it's more we are talking about distributed processes across microservices, and when we are talking about Kubernetes operators, it's more how to schedule the runtime of various services pods in a Kubernetes environment. So for me, it's a little bit different. No?
For example, Search Manager, how it's working, it's enough
Okay. Okay. Yeah. No. So I understand. So you can actually, yeah. So you can use some Kubernetes native way how to do orchestration, where each step is basically a job or something like that, right? That's what you mean. Yeah. Yeah. That's a valid approach. Now, this is a little bit more close to infrastructure. So I would say it's a little bit more difficult to explain to developers how to work with that, but definitely there are also like, I think, CI/CD tools that use that kind of concept where each step is like a container that is independent, etc. So yeah, that's a valid approach, but I would say it's more for geeky environments, less usable when you will have like, for example, developers in TypeScript, etc. So it will be very difficult. Like as we said previously, like not every developer wants to have Terraform and to have this kind of tooling in their head, you know. So it's a valid approach. It's a native from Kubernetes point of view, but it's a little bit more difficult to adopt in a full enterprise.
So we have last two questions. So when applying zero trust policy, what were your biggest challenges?
So the biggest challenge is the security guys, you know. The problem is that zero trust, I think it's very good, but it's very difficult to convince people that it's enough. And the arguments of the security people are fair. You know, they say, okay, I like zero trust, that's good, but it makes sense to also have something else, you know. It's never good to just protect one side of, or one aspect of the thing. It's better to have also other aspects. So then you may end up with having zero trust, so you have certificates everywhere, you have MTLS, you have you know, GWT everywhere, fine. And then at the top of that, you will have firewalls, and you will need to have you know, security exceptions for every pod-to-pod communication, and you will end up with 2 times the effort. So the challenge is that you need to trade something for the zero trust. Zero trust puts some challenges to every developer or every service to have some kind of awareness of the authentication, authorization, and the kind of stuff. But it should be easier than just to deploy a service everywhere, like to run it from localhost. Why not, you know? And so you need to trade for it, and it's a challenge because in security conferences usually this is not something considered as sufficient to have an open communication and to have zero trust. So that's the main challenge. Then of course another challenge is that some people will try to hijack the concept of zero trust. They say, yeah, I like it. Let's put an API gateway, and it's going to be our zero trust. I mean, that's not zero trust. You have the API gateway, so then you want to provide a new service. You need to provide a new service, and then you also need to deploy the new REST open API documentation to the API gateway so that you can communicate. You need to have some service discovery, etc. So for me, zero trust is good, but you need also to convince and to prove that you're enough mature to not require too much of other security kind of limitations. So that's the main challenge. It's not technical, it's more process-wise and people-wise.
Okay, so the last question is, how orchestration like Camunda temporal can be implemented with active DR multi-region?
So you need to understand what is orchestration. Orchestration cannot replace everything. Yeah? For example, let's say we have a service that's gonna provide some services to the clients, which can be thousands, millions clients from their browsers. They access a service, and you want to authorize the request. So typically, you can implement either JWT, which is nice because you don't need any cache. You have the token that is provided by the client. But maybe for some scenarios you want to have, for example, some API key, and you will implement an HMAC, signature and things like that, where you don't have JWT. Then you need to cache the API key on the service that receives the request. And if you have zero trust, you don't want to have any kind of API gateway in the between because it's just an overhead for you. So then you need to invalidate the API key in case somebody changes it or somebody is discredited, etc. So for this kind of scenario where you want to tell your infrastructure that the API key is no more valid or a certificate is no more valid, basically orchestration doesn't work because you don't know what's the number of instances of the service that has cached this stuff. So for this kind of scenario, typically you need event sourcing, where you will just issue the event, like, I mean, this API key is no more valid, and every service that validates a request will need to consume this event. So first thing is that let's clarify orchestration cannot handle everything, yes? Second, so what handles orchestration? Orchestration is typically just a chain of RPCs. So that's the orchestration. So you want the transaction to happen exactly once, but there's a chain and it can be very rich. There's a graph of operations to be done. So in that scenario, you don't care where it happens. If you have active, it can happen in one data center. And if it happens, you're fine. Now, the next step is something else. So you just then rely on the replication between active. So of course, for example, if you have some delay for the replication between active, the first transaction step is done on the first data center, and then the next step should, by chance, is done on the second data center, which did not yet receive the state from the first data center. It's going to fail because it will say you, for example, you have a new customer, you want to add a service to the customer, right? So first microservice in the first data center will create the customer, and then the second microservice in the second data center will try to provision a service to the customer. And the customer has not yet arrived. Even if it's active, let's say it has not yet arrived. So it's going to fail. So orchestration, whether it's Camunda or any other platform, will help you because they will retry a little bit later. The first attempt will fail, and you will retry a little bit later. You could achieve the same with event sourcing. If the second service is going to consume an event like customer created, okay, let's provision the service. It can just wait until the customer is propagated where it needs to be propagated. Yeah. So the orchestration pattern is relying on retries and eventually compensation in case it fails. So if you have active, I think it's not a problem for orchestration, and orchestration actually helps to leverage that you have this kind of architecture.
So thank you, Ashik. It was the last question. So that's all.
Thank you.
Don't leave. You can still join us. We still have some, I think 2 hours at least. So just take some beer and we can talk about stamps in person. So that's it. Thanks.